So here we will discuss some problems. So this is problem number 1. As you look here, this is from older question paper. I have written the data given. This is V1, that is inlet velocity of the jet. This is velocity of vane inlet. Angle of jet at the inlet is 30 degrees and outflow is radial. Outflow is radial, the meaning is angle beta is 90 degrees. Now what is to be found? To be found are theta and phi. That is, the inlet and outlet angles of the vanes are to be found. Now this information, if we convert into triangle, 40, angle is 30, this u is 20. I'll complete the triangle. You extend this line, draw a vertical. This particular side is known as velocity of whirl, which can be readily calculated as 40 cos 30. And this side is known as velocity of flow, which is 40 sin 30. It is 20 and this is 34.64. Out of this, already this is given to be 20. This I can calculate, which will be 14.64. Now using this 14.64, this 20, I can calculate theta by writing an expression of tan theta. So theta can be worked out, which comes out to be 53.79. Now knowing this side and this side, I can always calculate this one, which is VR1, that is relative velocity at the inlet, which can be calculated using Pythagoras. So this comes out to be 24.79. Now we'll discuss the outlet velocity triangle in the next slide. So here it is. It is given that beta is 90 degrees because radial outflow, that is what is given. Radial in the sense it is perpendicular to you. So that information is already given. And if there is no mention, one can always assume that VR1 is equal to VR2. So already we have worked out VR1, which is 24.79. So the same thing will be assumed as VR2. So VR2, which is equal to VR1, equal to 24.79. So we know this, and because it is a tangential flow, U1 and U2 are equal, and that is 20. So this angle is phi, that is, this angle is phi. So I can always write VR2 cos phi equal to 20. VR2 cos phi equal to 20. So I can calculate phi, which is angle of vane at the outlet. So that is problem number 2. Problem number A is over. So this is problem number B. This again, this is from older question paper. The data given is velocity of the jet is given 45. Velocity of the vane is mentioned u15. Because there is no mention of inlet or outlet, so obviously we can assume it as tangential flow. VR2 is equal to 0.9 of VR1. Generally we assume VR1 equal to VR2 if there is a mention like this. This happens because some energy is lost when the jet hits the vanes. So VR2 is given to be 90% of VR1 or 0.9 times VR1. Beta is mentioned as 90 degrees, that is radial outflow, that is the general condition, but they have to mention, otherwise beta is not equal to 90 degrees. Alpha is given to be 20, the angle between V and U is 20 degrees. What is asked to find is theta, phi and efficiency. So as you have discussed in earlier problem, this whole thing can be carried out. So we can work out theta. Tan theta will be nothing but this side, which is V sin alpha, divided by this much, which is nothing but V cos alpha minus U. That can be taken as a ready formula, or you can work out individually the distances. After writing expression for theta, one can calculate tan theta. Now VR1 can be calculated, it is 31.33. Okay, here VR2 is calculated as 0.9 times. VR2 is calculated as 0.9 times VR1. So VR2 comes out to be 28.19. This is outlet velocity triangle. VR2 is 28.19. This angle is phi. U is given. U is given to be earlier value of U is 15. So I can write VR2 cos phi equal to U. VR2 cos phi equal to U. Now only unknown in the equation is phi. So phi comes out to be 87.86. Now in this velocity triangle, V2 is vertical. Because of that there is no horizontal component. Because of that it is velocity of whirl is 0. And this whole of V2 becomes velocity of flow. Now having known VW2 and then earlier VW1, VW1 was 42.29. So knowing these two values, we can calculate efficiency. Efficiency expression, we already known that it is 2U into bracket VW1 plus or minus VW2 V1 squared. 2U is given to be 15. W1 is 42.29. VW2 is 0. So there is no question of plus or minus here. This we'll see in next problem. If the plus sign is when beta is less than 90 degrees, minus sign is when beta is more than 90 degrees. So efficiency comes out to be equal to 62.65%.